This aircraft was never meant to be here.
Built to dominate the sky, it now lies silent beneath the ocean.
Seawater has been attacking its structure for years.
Every system was designed for air, not salt water.
At this depth, pressure and corrosion work together.
Damage like this is slow and unforgiving.
The question is no longer how it got here. The real question is, can it still be saved?
Finding an aircraft underwater begins long before anyone dives.
Radar sees the surface. Sonar reveals the...
Sound travels where light cannot. Autonomous vehicles descend where humans cannot.
The target is confirmed.
Corrosion patterns reveal how the aircraft settled.
Engineers study which parts still carry strength.
Control surfaces suffer first underwater.
Design choices made for flight now define recovery risk.
Only specific points can support lifting forces.
Some damage cannot be reversed.
Every measurement determines whether recovery is possible.
At this stage, nothing is lifted.
Because lifting too early could destroy what remains.
Before recovery begins, engineers must decide if it should.
Is lifting this aircraft even possible?
If these joints fail, the aircraft will tear apart.
The tail often carries hidden stress. Engines are never lifting points.
Only a few areas can safely carry load.
Balance is more important than strength. Only primary load paths are considered.
Once recovery begins, there is no second attempt.
Recovery begins without haste.
Attachment points determine survival.
Buoyancy reduces strain on weakened metal.
Nothing moves yet. Time has bonded metal to the ocean.
Balance is constantly monitored.
Uneven load could tear it apart. The seabed releases its grip. Movement begins slowly.
The surface is still far away.
Ascent must remain constant.
Gravity and buoyancy fight silently. Recovery is no longer a question.
It is now a responsibility.
Water release changes weight instantly.
Balance must be corrected in seconds.
Only reinforced structures carry vertical load.
Hovering prevents sudden shock. Load transfer is gradual.
Drainage continues long after lifting. Assessment replaces urgency.
Every flaw is documented.
Environment control prevents further damage.
Only now can restoration truly begin.
Lowering is more dangerous than lifting. Every surface tells a story.
Salt water locks metal in place.
Damage is often worse below the surface.
Hidden corrosion defines repair limits. Major components are isolated. Engines rarely survive immersion. Electronics and seawater never coexist.
What remains will define what survives. Restoration is not about saving everything.
It is about choosing what must survive.
Some strength still remains beneath the rust.
These components can be preserved.
Certain materials resist corrosion better than others.
Composites often fail silently.
Some damage cannot be repaired safely.
Electronics are always replaced.
Engines demand the highest standards.
Elimination is part of protection.
Preserving technology sometimes means destroying hardware.
Replacement is not imitation.
Every decision is verified.
Reassembly begins only after the damage is fully understood. Structural alignment comes before appearance.
Only primary load paths are restored. The wings return first.
Seawater dictates where reinforcement is required.
Precision defines survival.
Engines follow structure. Mounting points carry the load.
Joints fail before surfaces. Electronics are replaced. Structures are preserved.
Sensitive systems are isolated.
The aircraft becomes whole again.
Millimeters decide flight. Fluids reveal hidden damage. Systems awaken carefully.
Nothing is assumed safe.
Now, the surface can be protected.
Structural reassembly is complete.
The structure holds the history of its descent. A warrior rebuilt from the depths.
The skeleton is strong. The skin is next.
Before restoration begins, the aircraft must be fully understood. Years underwater leave damage that cannot be seen at first glance. Saltwater attacks joints, seams, and connections first. Every millimeter of the airframe is digitally measured.
Damage is categorized by repair feasibility.
Control surfaces often suffer permanent damage underwater.
Stealth materials are especially vulnerable to seawater.
Even minor corrosion can affect airflow and stability.
Contact with the seabed adds structural stress.
Hidden damage often defines restoration limits.
Electrical systems rarely survive saltwater exposure. Avionics are among the most fragile systems.
Most electronic components must be replaced.
Engines suffer contamination, even when inactive.
Mounting points determine structural survival.
At this stage, data becomes more important than metal.
Internal bays introduce additional risk. Each material reacts differently to seawater.
Deviation from design limits defines repair boundaries.
Not everything can be saved. Some parts must be sacrificed to protect others.
The true condition lies beneath the skin.
The aircraft is no longer complete.
Only critical load paths are preserved.
Emotion cannot guide restoration.
The decision is made.
Restoration will be selective.
What survives will define what returns.
Now, restoration can begin.
Surface treatment begins after structure is secured.
Salt residue must be removed completely.
Even invisible damage matters.
Protection replaces exposure.
Coating is functional, not cosmetic.
Consistency defines performance.
Surface behavior matters more than color.
Environment control prevents future failure.
Some marks are left intentionally.
Inspection begins immediately.
Strength must be proven.
Movement reveals weakness.
Response replaces theory.
Systems return in sequence.
Stability matters more than speed.
Power is measured, not unleashed.
Excess reveals hidden damage.
Data decides readiness.
The ground will soon let go.
The structure has passed.
Now, it must fly. Testing begins where certainty ends.
Power is introduced gradually.
Acceleration reveals truth.
Lift conforms balance.
The sky accepts it again.
Control returns.
Structural integral integrity holds.
Speed increases gradually.
The aircraft remains within limits.
This is not a demonstration.
It is confirmation.
Nothing exceeds tolerance.
The test phase concludes. Return is as important as departure. Stability remains constant.
Every mechanism must respond.
Contact confirms success.
The aircraft is airborne no longer, but it is proven.
This aircraft was never meant to return.
Salt water leaves permanent memory. What mattered was not perfection.
It was understanding. So outstanding.
Restoration is not about erasing history.
Some machines are built to fight.
Others are built to teach.
This one did both.
If this story made you think,
Subscribe to follow the next recovery.